After you've built your very first network, then chances are you may be asking yourself, well, how do these devices talk to one another? Or in other words, how should they talk to one another? Well, just like humans who have rules and structure or grammar as we know it for us to communicate our thoughts effectively, computers work through a similar system, but except through the manner of sending and receiving data instead of sharing their literal thoughts. And so that is when the networking model comes to play. And what a networking model really is, it's just a framework or a blueprint for how data is sent and received through a network. And there are two networking models as we know of today. One is called the TCP/IP model, which is the standard, which is what computers use today to send and receive data through a network. And then there's another one called the OSI model, or the Open Systems Interconnection model, which is a reference model based on the TCP/IP model, where students, teachers, and learners alike will definitely use it to understand network communication even further. And so let's start by exploring the TCP/IP model. And what you see there is an empty white box with 5 layers. And each layer represents a literal layer of this model, or a step in the model. And so the first one from the top is called the application layer. And so what it does is that it provides us users some way to interact with the network. And so how this works in practice is by literally searching something up in the internet. It's something that you do every day, so let's do just that. Let's search up for, I don't know, cat videos. So in my search bar, I will type cat videos. And then Brave browser has returned to me several cat videos or anything related to cats. But I'm more of a dog person, so let's search up for dog videos. So again, let's go to my search bar and type dog videos. So I will do just that. And then the browser has returned to me once again with dog videos. So by searching up cat videos or dog videos or anything in the internet, you are sending what's called an HTTP request. So how this works underneath the hood is by searching up for cat videos, you are requesting something. You are sending out an HTTP request. And then the server that received my HTTP request will respond to me with an HTTP response. So that in the form of cat videos. So the server that received my HTTP request of cat videos has replied to me with cat videos or anything related to cats. So that is how the HTTP or the Hypertext Transfer Protocol works. And there are a lot of application layer protocols too, like FTP or SMTP or SSH or Telnet. All of those protocols will share something in common. And that is to provide us with an interface to interact with the network. So that is the application layer. The next layer of this model, which is right below the application layer, is called the transport layer. And so what it does is that it provides devices a secure connection for them to talk to one another. And so how this works in practice is by browsing the internet once again, but this time, let's say that I was unaware that my internet was switched off. And then somehow I naively searched up for kitten videos. And what do I get? I get nothing. And so what we saw there was the transport layer failing in action. Instead of seeing it work, we saw it fail. And so let's fix the issue. Let's say that I figured out what the issue was, and that's really just my internet was switched off. And so let's search up for kitten videos once again with my internet back on, and hopefully we get something. So as I search up for kitten videos, I now should get something. So queries of kitten videos or anything related to kittens. So what we saw there that failed in action was the TCP handshake or the three-way handshake. Before I send out an HTTP request out there, I first must need to establish a secure connection to a server. And so the first part is by sending out hello packets or SYN packets out there in the internet. So you're saying, hello, I am Bob. You are introducing yourself out there. That is the SYN packet. That is the first part of the handshake. And so the server that receives my SYN packets responds to me. Hi Bob, I'm George. So it acknowledges me and also introduces itself to me. So that is the SYN ACK packet or the second part of the handshake. and then my computer finally acknowledges that server, and now my computer and the server are now fully connected to each other. That is when my computer starts to send out HTTP requests to that server. And so that is the transport layer. Is that it provides us a secure connection to a server or to another device so that both devices can talk to each other without any problems. The next layer, which is right below the transport layer, is called the network layer. And so let's see this work in practice right now by opening up Packet Tracer. And what I have here is I already have a topology made for you. So I already have a pre-configured router and two devices that are in totally different networks. So let's go to this computer here, 192.168.1.1. And from here, I want to ping 10.0.0.1, which is the other computer. So by pinging 10.0.0.1, we get what's called the ICMP replies or ping replies. So by pinging 10.0.0.1, we can tell that my computer here, 192.168.1.1, is connected to 10.0.0.1, which is in a totally different network. And so let's test if the connection works both ways by pinging 192.168.1.1 from 10.0.0.1. So I can do that by pinging, or put the ping command in there and put the IP address of the other device, 192.168.1.1. And there we have it. The connection works both ways. So we can now tell that 10.0.0.1 is connected to the other network, which is 192.168.1.1. And so what we saw there was the network layer in action. And so this router, which operates in the network layer, makes sure that my two devices from totally different networks can communicate to one another. So that is what the network layer does, that it connects two or more different networks together. The next layer right below the network layer is called the data link layer. And so we'll see how this works in practice by opening up Packet Tracer once again, but this time I have a different topology built for you. So I have these three devices connected to the same switch, and so we know that these devices are in the same network, and I want to test if these connections really work. And so let's open up the command prompt on 192.168.1.10, and let's ping 192.168.1.1. Okay, so we know that works. I'll just press Ctrl plus C to cancel the entire process right away. And let's ping 192.168.1.20. Okay, so we can ping both devices, but guess what? We're not actually using IP addresses to communicate to these two other devices. We're using what's called MAC addresses, or Media Access Control addresses. They're represented by 12 hexadecimal digits, as you can see right there. The label right there, that's right below these desktop computers, these are MAC addresses. So the ones that start with 00, those are MAC addresses. And these MAC addresses are physically integrated to your device, so you cannot change them whatsoever because they're physically associated with your device. And so what the data link layer does is that it provides us a connection with the other devices within the same network. So again, instead of having a source and a destination IP address, we're using source and destination MAC addresses to talk to the other devices within the same network. And the final layer in the TCP IP model is called the physical layer. So how does the physical layer work? Well, let's open Packet Tracer and let's build a very simple network from scratch. So we'll start by adding a switch, and then we'll add two computers. And so the big question when it comes to the physical layer is that, can these devices physically talk to one another? That is, can they send electrical signals to one another? Well, the answer right now is no, because we haven't cabled our devices yet. So let's cable them right now. And in theory, these devices should now be able to physically communicate. That is, they should now be able to send electrical signals to each other. And so that is the whole job of the physical layer. That is to transmit whatever data that computer may send as electrical signals. So these electrical signals travel through that Ethernet cable all the way to the other device. After learning about the TCP/IP model, it is also important to know the protocol data unit for each layer. And so what I have here is a diagram which corresponds each layer in the TCP/IP model to its own protocol data unit. So the data is the protocol data unit for the application layer. For the transport layer, it's called the segment. For the network layer, it's the packet, the data link layer, a frame, and for the physical layer, it's a bit or bits. So all these terms, all these new terms that I showed you are really just collectively known as a protocol data unit, which is just a generic term for any unit of data that is represented in the networking model. So after you've heard about the TCP/IP model, it is also important to know what the OSI model is. So the OSI model has 7 layers. Instead of 5 layers, we have 7 layers. And the 2 additional layers are in between the application and transport layers. So the first one from the top is called the presentation layer. And let's see how the presentation layer works in practice by going to Google and searching up for a hex color picker. Okay, so now that we are in the hex color picker, let us look for red. So for the color red, I know that it is 2 Fs and 4 zeros. So FF0000 represents the color red. And now I want to look for color blue. Well, I know that color blue is 4 Fs and 4 zeros and 2 Fs. And so by typing out 4 zeros and 2 Fs, we now get the color blue. So by typing out the hex code for red or blue or any color out there, what you're seeing there is the presentation layer in practice. So what it does is that it translates raw data into something that we users as humans can understand. It does more than translating data though. It can also compress or encrypt data, but what we saw there in practice with the hexadecimal color picker is that it translates raw data as represented by the hexadecimal code into something that I can intuitively understand, such as the color red or the color blue. And then finally, we have the session layer. So let's see what the session layer does by logging into a website like LinkedIn. So when I put my username and password and then click signed in, I should now be logged in into LinkedIn. So now that I'm logged into LinkedIn, let's just navigate for a bit because that's why I logged in here. I just want to navigate around the website. And then once I'm done, I just simply log out. So what we saw there was the session layer at work, and all that it does is that it manages communication sessions between myself and LinkedIn's website. So the moment I logged in into LinkedIn's website, it opens that session between myself and LinkedIn. It then maintains that session for a bit, especially when I'm interacting with the website. And then finally, when I log out, it then closes that session. So this is what I mean by the OSI model being a reference model, is that each layer is very commonly referred to as layer numbers. So for example, when I say something like, this has got to be a layer 3 problem, what I'm basically saying is that there is a problem in the network layer and we gotta fix that. And just like the TCP/IP model, the OSI model also has protocol data units, and they look exactly the same. The only thing to watch out for here is that layers 6 and 5, their PDUs are referred to as data as well. And why is that? Well, technically that's because the presentation and session layers are part of the application layer in the TCP/IP model. So to summarize everything, we explored what the TCP/IP and OSI models are, but instead of working through the theory of everything, we saw how each layer works in practice. So that's it, guys, and I hope you learned something.